Hello everyone, Gaza Mutkash, and I welcome you all to the session on data preparation for BI and analytics. So let's have a look at the agenda for this session. The agenda for this session includes understanding what is meant by hierarchical data, and then we'll be implementing the flattening of hierarchies. So till the previous session, we have discussed the data denormalization. So let's proceed with understanding what hierarchy is all about in MySQL, and then we'll be implementing the same in Power Query in Excel. So guys, over here we are in the MySQL workbench. So first of all, we need to understand what do we mean by hierarchy. So hierarchy over here simply implies, let's say, there is a sequence or order in which the entities, let's say, are aligned. For instance, let's talk about the hierarchy in the online products, right? So in the online products available, there is a predefined hierarchy. So on the top level, let's say this is the top level, right? On the top level, let's say we have electronics. In the electronics section, so inside electronics, we can have maybe, let's say mobile, we can have tablet, all right, we can have laptop, all right. So this is, let's say, level 1. What we have over here is level 1. Now these three are level 2. They're all level 2. Then even this is level 2, and even this is level 2. So these three are at present at level 2. Next, so if we drill down further, so inside mobiles, maybe we can have, let's say, handset, then maybe we can have Android, and then we can have iOS. All right, so these are the three. This is for then so this would be level 3. This would be level 3. All right, currently we are just trying to understand the concept of hierarchy. This is level 3, and even this is level 3. So likewise for tablet, maybe we can have Android, and then we can have iOS. So again, there can be two kinds of tablets. So even this is level 3, and even this is level 3. Likewise for laptop, we can have Windows, then we can have iOS, and we can have even Linux. So all these are level 3. Means this is the further hierarchy that we are drilling down, right? This is the hierarchy that we are drilling down. So on top we have the electronics. This is spelling mistake. This is electronics, and then we have the mobile. So mobile is further categorized into handset, Android, and iOS. Tablet is further categorized into Android and iOS, and laptop is further categorized into Windows, iOS, and Linux. So again, these are the hierarchy, right? We can further drill down maybe Android into maybe some sort of maybe they're based on RAM, based on the camera, all right. So this can further be drilled down. So on the level 1, we have electronics, which is further divided into mobile, tablet, and laptop. Now mobile is further subdivided into handset, Android, and iOS. Tablet is further subdivided into Android and iOS, and laptop is further subdivided into Windows, iOS, and Linux. All right. So this is how, let's say, the hierarchy is maintained. So we have to follow the hierarchy and accordingly, let's say, generate the results. So this is how, let's say, we can understand the hierarchy. Next, let's understand the concept of flattening hierarchies. So flattening hierarchies simply indicate that we are transforming a multi-level parent-child relationship. So over here, clearly we can see parent-child relationship. So mobile, tablet, and laptop are children for electronics, and electronics is a parent for mobile, tablet, and laptop. Likewise, handset, Android, and iOS are children for the parent mobile. Tablet has the children Android and iOS, and laptop has the children Windows, iOS, and Linux. So we do have a parent-child relationship, right? So when we are flattening the hierarchies, we simply mean that we are transforming a multi-level parent-child relationship like employee, manager, director into a single level tabular structure that is easier to read, analyze, and even visualize, particularly useful for dashboards and reports. So this is what is essentially utilized in dashboarding and reporting. All right, this is highly used in dashboarding and reporting. So let's understand the use case and the purpose. So a few particular examples could be employee reporting chain. Every employee reports to maybe the team lead or the manager. So what is the entire reporting chain? So in the description over here we can see show who reports to whom. So this could be first level hierarchy, second level hierarchy, and so on. Then we have the product categories. So over here we can convert nested categories into a flat view. So product categories, just as I've mentioned, this is an example of product category, right? So this is the example. Example is simply the product category. This is what we have. So next, if we check organization chart, so map all reporting relationships in one row. So we do have organizational charts, then we have location hierarchies, maybe we have country, state, and city. So maybe a particular region, and even inside the city we do have the region, right? So region slash location. So again there is a hierarchy being followed. So inside the country we do have the state, inside the state we do have the city, inside the city we do have the region slash location. Alright, and inside maybe region slash location, maybe we have a particular landmark. So this can also be considered as a hierarchy, right? So let's understand the purpose and the benefit. So the primary purpose is reporting. So when we are creating a hierarchy, let's say we are flattening the hierarchy, essentially we will be utilizing it for the reporting, right? So it is easier to show full reporting paths. So this was the primary purpose. So this is the benefit of, let's say, reporting the hierarchy. Next is the data modeling. So it is needed for flat table structures in BI tools. Next we have the dashboard visualization. So this is where filters and slicers work better with the flat structures. And then we can also have easier joins. So if you are using hierarchy, we'll have easier joins. You can avoid repeated joins during the analysis. Alright, so at the time of analysis, it becomes much easier when we are, let's say, utilizing the flattening concept. So over here, we'll be looking at a very classic example of employee and manager, employee and the supervisor. So we'll be looking at the concept of employee and the supervisor. Over here, I'm creating the table called employee 1. And in the employee 1 table, I'm having the employee ID, which I'm setting it to primary key, integer primary key, means all the employee ID will be unique. Then over here, I'm writing employee name, which I've set to the varchar. Employee name is set as the varchar 20, means the employee name cannot have more than 20 characters. Then over here I'm passing the date of join. So what is the date of join for each employee? I'll be adding it in the date time field. Then over here I'm adding the salary is set as integer. Then I'm having the employee supervisor. So employee supervisor is nothing but the primary foreign key referring to the employee ID, and employee supervisor का जो data type है वो हमने integer set किया है. Next over here I can see the foreign key. So in the foreign key over here we have the employee supervisor, which is referring to the employee 1 employee ID. Alright, this foreign key employee supervisor, this is the employee supervisor. This is referring to employee 1 ka employee ID, right? This is what it is referring to. It is referring to the primary key of the same table. So this is an example of self join. This is an example of self join. This is what is utilized in flattening hierarchies. This is the concept which is utilized in the flattening of hierarchies, right? So maybe I can mention it over here. So some SQL advanced concepts such as, let's say, self join. Self joins are used to flatten the hierarchies. Likewise, let's say further advanced concepts like recursive CTE. Recursive CTEs are used to, let's say, flatten the hierarchies. Even recursive CTEs are used to flatten the hierarchies, right? So these are the concepts that we use. So let's have a look over here. So we have the employee table, and this is the data, right? So let's try to understand the first question. Let's understand the data. So in the employee table over here, I've entered these values. If I were to display the data, this is the data that we have. So we have 6 rows of data. Let's observe the data that we have. What have we inserted over here? Over here, I'm having employee ID, which is 27863. Employee name is Ankit Sinha. Date of joining is 2018-613. The salary is 1,50,000, and the employee supervisor ID is null. Then for 27865, the employee name is Mridul Paliwal. Date of joining is 2019-814. The salary is 95,000, and the employee supervisor is 27863, which is again corresponding to this employee. Next, we have 27867 Shweta Sharma. That the date of joining being 2020-1225. The salary is 1 lakh 3500, and the supervisor is 27865, again Mridul. For Vinay Sharma, the employee ID is 27869, the supervisor is Shweta. And for Pratyush, the employee ID is 27871, the supervisor is 27865, as in again Mridul. Then for Ranveer, the employee ID is 28763 and the supervisor is 2876. This is 27873 and the supervisor is 27863, as in Ankit. So clearly there is a hierarchy between the employee and the supervisor. So first of all, let's try to find all the employee name, supervisor ID, and the supervisor name from the employee table. So this is where we are flattening the entire data. For each row, I want to find the employee name, the employee ID, the employee supervisor name, and the employee supervisor ID. So how would I write? So I'm considering two copies of the same table, employee 1 E1 and employee 1 E2. So over here I'm writing let's say, or employee 1 as employee E and employee 1 as supervisor S. So E dot employee ID referring to, I'm considering the employee table as the employee as employee ID. Then E dot employee name, I'm considering the employee table as the employee name. All right, and then over here I'm having S dot employee ID. So S dot employee ID indicates let's say supervisor table employee ID. So again, we don't have a supervisor table. We are considering the employee itself as the supervisor because the same employee table contains the data for the supervisor ID as well. So this is the supervisor ID and S dot employee name as the supervisor name. From employee 1E, which is referring to the employee, and employee 1S, which is referring to the supervisor. So now what is the logic? So if we observe the data, over here, what is the logic that binds the employee and the supervisor? So clearly let's say the supervisor ID for the employee, the supervisor ID for the employee. So employee dot supervisor ID should match the supervisor dot employee ID, right? So this is what I've mentioned over here. S dot employee ID is matching with E dot employee supervisor ID. Wherever let's say the employee super ID, the supervisor ID for the employee matches with the supervisor employee's ID, right? So for example, for the employee 27867, the employee supervisor ID is 27865. 27865 is the employee supervisor ID, and this should match with the supervisor ID of the employee. So 27865, what is the supervisor ID of the employee? Bearing the supervisor ID 27865, this is Mridul Paliwal. So for the employee, for the employee for whom the employee ID is 27865, these two things matches, right? So employee dot supervisor ID matches the supervisor employee ID. So this is the logic behind the self join. So this question we have solved. We have solved this question. This is solved using currently join, and let's call it the self join because this is the self join case. Even without using the join keyword, it can be solved using the same approach. So over here I'm writing select E dot employee ID as employee ID, then E dot employee name as employee name. Then over here I'm writing S dot employee ID as supervisor ID, then S dot employee name as the supervisor name, and then I'm passing from employee 1E, which is the employee, and then employee 1S, which is the supervisor. What is my joining condition? E dot employee supervisor, which is same as S dot employee ID. So this is what we have, and let's run this. So again I'm getting, as you can see, just observe the output. For the employee ID Mridul Paliwal, the supervisor ID is 27863, which is Ankit Sinha. For employee 27867 Shweta Sharma, the supervisor ID is 27865, which is Mridul Paliwal. So this is how the flattening of the hierarchy looks like. Then for employee ID 27869, the Vinay Verma, the supervisor is 27867, which is nothing but Shweta Sharma. For employee ID 27871 Pratyush Singh, the supervisor ID is 27865, which is again Mridul Paliwal. Then for employee ID 27873, which is Ranveer Pratap, the employee supervisor ID is 27863, which is Ankit Sinha. So even with let's say self join or even without using the join keyword, we have obtained the same results. So ये अभी हमारा data मिला है. Now can we extend the hierarchy beyond this? Yes. So first of all, let's try to find a few more details, right? Let's try to find few more details. So another question that is commonly asked in the interviews: find all the employee ID, employee name, employee salary, then supervisor ID, supervisor name, supervisor salary from the employee table where employee is earning more than their supervisors. So we have to figure out the employee who is earning more than their supervisors. So how would you approach this problem statements? Over here again I'll be considering two copies of the same table, employee table as E and employee table as S, referring to the supervisors. So over here I'm having select e dot employee id as employee id, then e dot employee name as employee name, then e dot salary as the employee salary, and then s dot employee id as the supervisor id, s dot employee name as the supervisor name, and s dot salary as the supervisor salary, right? So these are the column descriptions that I've added from employee 1 as e, which is referring to the employee, and then from join employee 1s, which is referring to the employee table as supervisor. Then what is the joining condition? My joining condition over here is on s dot employee id matches with e dot employee supervisor id, and where e dot salary is greater than s dot salary. So this is the joining condition that links the employee supervisor to the supervisor id. The same condition that we have just seen over here. Employee supervisor id should match the supervisor dot employee id. But there's another constraint that the salary of the employees should be more than their supervisors. So this is what we are implementing. Alright, so we just have one employee, which is Shweta Sharma, and she is earning more than the supervisor, which is Mridul Paliwal. So this is how we have solved this problem. So this is the second question that we have solved. Then next, the third question is, now this is further drilling the hierarchy. This is where we are drilling the hierarchy even further. So I want to find all the employee ID, employee name, manager ID, manager name, then the senior manager ID and the senior manager name. So this is like drilling 2 levels down the hierarchy. Over here, I'll be drilling 2 levels down the hierarchy, right? So let's have a look how to implement this. So to implement this, what are we doing? Over here, I'm writing select e dot employee ID. So e is referring to the employer. All right, employee table as employee ID. Then I'm writing e dot employee name. So again, e is referring to the employee table, employee name. All right. So when I'm using the alias e, so I'm referring to the employee ID and the employee name. All right, at the lowermost level as employee name. Then I'm referring to m dot employee ID. So m is again let's say alias for the manager. All right. So m dot employee ID is referring to the manager ID, and m dot employee name is referring to the manager name. This is the immediate manager name. All right, manager, or I can say immediate manager. This is the immediate manager, immediate reporting manager. All right, this is going to be the immediate reporting manager. So m dot employee ID as manager ID and m dot employee name as the manager name. This is the immediate manager name. Then sm dot employee ID, senior manager dot employee ID as senior manager ID, and senior manager dot employee name as the senior manager name. From the employee table 1e, and I'm joining it with employee table 1m on what is my joining condition, e dot employee supervisor, which matches with m dot employee ID. See, employee supervisor, this is the same condition, employee dot employee supervisor should match with supervisor dot employee ID. So in this table we have not considered supervisor, rather we have considered the manager, right? So this is the immediate reporting manager. So m dot employee ID. So this is the first part where I'm linking the employee to the managers. Next, and again I'm joining with the employee table, which is referring with the alias sm referring to the senior manager, right? And what is the joining condition over here? So over here the joining condition would be manager dot employee supervisor. Manager dot employee supervisor should match with the supervisor senior manager dot employee ID. All right, over here the joining condition is whenever the supervisor ID for the manager matches with the employee ID for the senior manager, that is the joining condition. So over here this sums up, this is drilling three levels down the hierarchy, right? So this is 3 levels drill down the hierarchy. This is referred to as let's say drill down the hierarchy. And up to how many levels? 3 levels. We are drilling down the hierarchy up to 3 levels. So let's execute this and check. So if I were to execute this, we can check for the employee ID 27867, the employee name is Shweta Sharma, the manager ID is 27865, the manager name is Mridul Paliwal, and for the manager Mridul Paliwal, the senior manager is 27863, and that is Ankit Sinha. Next, for employee ID 27869, the employee name is Vinay Verma, the manager ID is 27867, which is Shweta Sharma, and the senior manager for the Shweta Sharma is Mridul Paliwal with the employee senior manager ID of 27865. Then we have the employee ID 27871, which is the employer name is Pratyush Singh. The manager ID, the corresponding manager ID is 27865, and the corresponding manager name is Mridul Paliwal. Alright, the corresponding manager name is Mridul Paliwal, and then the senior manager name is 27863. So this is the senior manager name, and then the senior manager name that we have over here is Ankit Sinha, right? For 27863, the senior manager name is Ankit Sinha. So guys, this is what we have. This is how, let's say, we can flatten the hierarchy and we can drill down on the hierarchy. So having understood these concepts, so I'm opening an Excel file and will be implementing the same concepts in the Excel as well. So let me save this data. This is the data, so I'm exporting it to some Excel workbook. So let's say I'll call this, let's call this employee and EM. All right, employee and the manager. That's it. And I'm saving it as okay. Let's save it as CSV only. No issues. EM. All right. So I've saved this. Now in Excel, I'll be opening this because we'll be executing the same concept in the Power Query. So let's go to data, and over here we'll get data from the file from Excel workbook. So I'll show you how to drill down one level down the hierarchy to flatten the hierarchy, right? So this is a CSV file, right? So from data, from file, the file that I'm using is text CSV, and this is EM. So this is the data that I'm importing, and on this data we'll be working. So guys, this is the data that we have. There are only 6 records of data. So let's click on transform. So transform simply opens up the Power Query. All right, and this is what we have. Now, if you observe, the employee ID is clearly integer, but the employee supervisor ID is not integer, right? So because we have null value over here, we need to handle this. But first is employee. So I'll be, let's say, creating a duplicate of this, and I'll call this manager. This is the manager. All right, and this is the employee. So I'll just rename this to employee. So we have the employee and the manager. So over here, the employee supervisor ID, this should match with the employee ID, right? So in the manager table, first of all, I'll get rid of the employee supervisor. So I'll simply remove this, and let's rename this. So I'll be renaming this as manager ID and then manager name, then the date of join, and this would be the manager salary. Manager salary. All right, so these are the changes that I've made to the manager table, but there are a couple of more changes that needs to be applied. So in the employee table, we do have this null as the string, right? Null is present as a string, due to which the data that we see over here contains null. So what can be done? We can simply replace the values. So right click, I'll have to replace the values. What values am I going to replace? I'll simply replace null with 0. So once this is transformed, yes, null has been transformed to 0. Next, what I can do, I can change the data type to integer or the whole number. So now we have the employee data and the manager data properly ready. So we have to merge the two tables to flatten the hierarchies. So over here, I can go to merge queries. So I won't be merging it like this. Rather, I'll be merging it new, merge queries as new. And then over here, once we are over here, so in the employee table, we have to ensure that the supervisor ID should match with the manager table manager ID, right? So this is the common link. This is what connects the two table. All right, so employee supervisor ID should match the manager ID, manager's manager ID, right? See, this is the logic that we have used over here. Employee.supervisor ID should match with supervisor.employee ID. So I'm replicating the same logic in Power Query Excel. So currently I'll be using left join, so that for all the employees we do get to see the corresponding managers. Maybe not for Ankit, because the employee supervisor ID is 0, or no, there's no match. So if we click on OK, so we do have the employee ID, employee name, date of join, salary, employee supervisor ID, and then for the manager we do get to see this table, so we can expand it. So once we expand it, let's say I can drill down to all these columns. So let's fetch all the details. So now we have the desired result. So we have a limited number of records for Mridul Paliwal 27865. All right, who is the manager ID? The manager ID is 27863. So at 27863, who is the manager? So manager is Ankit. Next, for the 27873, the employee name is Ranveer Pratap. The manager ID is 27863. So 27863 is again Ankit, right? Next, if we check, so next we have 27867. The employer name is Shweta Sharma, and the manager is 27865. And at 27865 we have Mridul, right? So over here we do get to see Mridul. Next, we have 27871. The employer name is Pratyush, and the employer ID is 27865 again, which is corresponding to Mridul. So for these records, we are getting correct result. For 27869, the employer name is Vinay Verma. The employer supervisor ID is 27867. At 27867, the employer ID is none other than Shweta Sharma, right? So this is what we get to see over here. So for all the records, we are getting correct. And for the last one, Ankit Sinha 27863, because there was no manager present in the original table who is superior to Ankit Sinha, or let's say the manager to whom Ankit Sinha reports. So the corresponding manager ID over here, the manager ID is null, right? And even the employee supervisor ID is null. So we cannot fetch any details for the manager for whom there was no manager ID in the first place. So guys, this is how, let's say, we can flatten the data. So maybe I can click close and load, and once I click close and load, the data would be loaded over here. So guys, as we can see, we have the employee and then we have the manager, and this is the merge where we have flattened the hierarchy, right? So in the merge table, we have obtained, let's say, flattened the hierarchy. This is where we have flattened the hierarchy, and this is an empty sheet. Maybe I can delete this. So guys, that brings us to the end of this session. So let me save this. So I'll be saving this as, let's call this M7B3. And this is the Excel workbook. So guys, that brings us to the end of this session. Let's switch to the PPT. So guys, in this session, we have understood the hierarchical data and its flattening concepts, and we have solved, let's say, a significant problem statement on the same. So in the next session, we'll be moving on to handling time series data in SQL. Thank you.